So we're going to start off by naming binary compounds. Those are the simplest compounds involving two elements, or two elements. They can be more than two atoms, but only two elements. So we have two categories. So if we look at compounds, again, remembering that a compound is two or more elements. So this binary compounds mean just two. So if you have a compound, you can either be a molecular compound, or an ionic compound. And the difference is simply where on the periodic table the elements are. So molecular compounds form covalent bonds, and these are when a nonmetal bonds to a nonmetal, where so they're both on the right side of the periodic table. So that would be like carbon plus O2 goes to form CO2. Okay, so these are both nonmetals, and this is a molecular compound. Okay, ionic compounds are form ionic bonds. And ionic bonds are formed when a metal bonds with a nonmetal. So in that case, we would have an example of like sodium metal plus chloride gas going to form Na plus. Well, we'll do this in a, we'll just say NaCl solid. And so this is your metal on the right or left-hand side of the periodic table. This is your non-metal, and this is your ionic compound. Okay, so we can name these in different ways. So, for example, if we look at this molecular compound, we would call this carbon dioxide. Now, you might be wondering when we are writing, so we have carbon and oxygen. Why does the carbon go first? Why don't we go O2C? And so when we order elements, when we're writing out these molecular compounds, we first order by the lower group number, remembering that a group is the column that the element is in. Goes first. So carbon, if we look at the periodic table, carbon, here's oxygen, so this is a lower group number. It is farther over to the left, so it's going to go first. So lower group number, and we can have molecules that are in the same group. So if that's the case, then the higher atomic number goes first. So an example of that would be if I had something like, let's see, SO3. If I had SO3, those are both in the same column, but because sulfur has the higher atomic number, we would put sulfur first, oxygen second. Okay? So that's for molecular compounds, so two non-metals. So if we were to look at ionic compounds, we are going to do positive. So ionic compounds, if we look at NaCl, this was formed from Na plus Cl minus. We always put the cation or the positive ion first because chemists are positive. We'd like to be positive, so positive first, and the negative anion second. Okay, um, so we can have rules for naming our. So that's just generally defining molecular versus ionic compounds. To actually learn how to name them, we have a couple rules. So naming binary compounds. So we're going to go and look at how we can go from the molecular formula. So there's a couple ways to do it. One is you're given the molecular formula. So we can use our example of like CO2, for example. And you're going to go to what the compound name would be, such as carbon dioxide. Okay, so what we're going to do is we're going to name. So let's for example do something. We're gonna have an example over here. We'll do NO2. So we'll have our little kind of example here, and we'll have the rules on this side, and we'll show how to use the rules. So I'm going to do the rules in different colors. So we'll start off with rule number 1, which is name the first element. So the first element's nitrogen, so we're going to write nitrogen. And then changing color, the second rule is change the ending of the second element to "ide." Okay, so if we have that, it would be, I'm going to do this in, so we have oxygen. So I'm going to replace the gin with oxide. So that's the second rule. And then the third rule would be to add a prefix. Add a prefix to indicate the number of atoms. So in this case, we have 2 oxygens, and so we would say dioxide. So it'd be nitrogen dioxide. Okay. So let's see if we can apply this to a new one. So if we have N2O4, then I would write nitrogen. Now I have 2 nitrogens, so I would need to put dinitrogen. We never put mono for the first term, okay? Only for the second term. So if you only have 1 nitrogen, like we had right here, we don't put mono. We just put di-tri. So that's dinitrogen, and we have 4 oxygens. So that's going to be 4 is tetra. But if we do oxide, it would be tetraoxide, and we only need 1 vowel. So we write this as tet. And then replacing the A, we just use the O. And then we still have the purple. So it's dinitrogen tetroxide. Okay. Let's do one more. So H2O. We already know this to be water, but this is a good example of when we have just 1 of something. So this would be dihydrogen space monoxide. So This is we also have the common name of water, but they're like memes and jokes going around where we talk about don't drink that dangerous chemical, dihydrogen monoxide. Um, or there might be signs in a lake that says dangerous dihydrogen monoxide, or the most deadly chemical in the world is dihydrogen monoxide because more people die of drowning than anything other chemical. So all of those are just based on the fact that water is very rarely called dihydrogen monoxide, but that is the official name for it. Okay. So lastly, we will talk about naming ionic compounds. I think ionic compounds are a little bit easier to name. Oh, let's do one. Let's do this in let's do let's go the other way. So if I said tetraphosphorus decoxide, then you would need to. I think it's easier to go this way. So I see tetra, I know this is 4. I see dec, I know this is 10. And this is phosphorus, and this is oxygen. So then I'm just going to write tetra, so I have P4. And then oxygen, I have 10. So that's a little bit easier. So if you want to look at ionic compounds, these are ionic compounds that have no net charge. And this is key. We have to make this assumption that these compounds combine in such a way that their charge is neutral or 0. That's key to our assumption we're going to make. So let's do this for, we'll start off with MgCl2. This will be our example, MgCl2. Okay, so our first rule, we'll do this in purple. First rule is name cation, so the positive ion, the first one. Name cation using name of the parent element. That's just a fancy way of saying you're not going to change the name at all. So magnesium stays magnesium. And then the second rule is to name the anion. Name the anion, where we change the ending to "ide." So similar to the molecular compounds. So we would say magnesium Cl is chlorine. Let me write that N a little better so you can see it. Is chlorine. So I'm going to change this to "ide." So it would be magnesium chloride. Okay. Now we do not need to put dichloride simply because I have looked at my periodic table. I can say, okay, magnesium is right here. Magnesium is in the second group, so it's going to have a +2 charge. Chloride is over here in the -1, -2. So chlorine is over here, so it's going to be Cl-. This is going to be Mg2+. And so I can go here and say, oh, well, I know that magnesium is going to be 2+, and chloride is, and so when I see magnesium, I go magnesium 2+, chloride minus, and I know that you just take these and say, oh, I need magnesium with a 1 and then a chlorine because it's 2+ with a 2. So you would just look at the name, and to go back to the molecular formula, you would just take the charge for the opposite. So the cation, you put the as a subscript for the anion and vice versa. Or to say it in a simpler way, you would just combine the ions in such a way that their charges cancel out in the lowest ratio of whole numbers. Okay, so let's do another example to practice. So if you haven't already, go ahead and when you see this, just pause it for a sec. So we're going to do, I'm going to write down a couple. I want you to pause this so that you can do some work yourself on this, and then I'm going to write one out, sodium sulfide. So I want you to pause this, and I want you to try to name lithium. Try to name LiF and aluminum oxide. Oh, sorry, giving it away, as well as sodium sulfide. So go ahead and name those, write them out, and then unpause and see what we do. I hope you paused it. Okay, so I already kind of gave these away, but Li is lithium, so we're just going to name that outright. So this is lithium, lowercase is fine. And then F is fluorine, so I'm going to drop the ene and put an I, so it's lithium. And then fluoride is Fl. Now it's UORID. Now it's not OU, that would be flouride, but it's fluoride. U comes before O. Easy thing to miss. And aluminum oxide is, so aluminum, 1L, and then oxide, it's oxygen, removing the gen and putting ide. Again, we do not need to say I have 2 aluminums and 3 oxygens because I can figure out the charge of aluminum is +3. So aluminum has a charge of +3, and that's why we have a 3 down here. Oxygen is a charge of -2, and that's why we have a 2 down here. We swap those charges for the subscripts. Now, to go the other way, sodium sulfide, we are going to say this is sodium. This is sulfide, so NaS. I'm just going to write NaS. If we look at our periodic table, we can see that sodium is group 1, so it's Na plus. Sulfide is here. That's S2 minus because it's 0, -1, -2, so 2 minus. So if we look here, we can say that this is 2 minus plus. So that means that this 2 would have to go here, so Na2, and then the 1 will go there, S. So Na2S would be how we would do sodium sulfide. Last one, and then we'll be done for this little section, is an interesting fact is tellurium in the ionic form, Te2 minus, is called telluride. Now, I am from Colorado, not originally, but I spent some 10 years there, and one of my favorite mountain towns is Telluride, Colorado. And now there's 2 stories of how Telluride got its name. The first is that the town itself had a lot of mining, and they found that there was a lot of Te2 minus near gold deposits, and so because this particular region was rich in tellurium, or specifically this ion of tellurium, telluride, that's how they got the town's name. But that's story number 1. The one that I like better is that telluride's off away from any major city, and so it was known for its lawlessness and sinful establishments, and so people thought that when you would go to that region, they would say, "To hell, you ride," or Telluride, and that was because of their sinful establishments. So, not sure which one of those is why Telluride got its name, but they're both pretty fun. One chemistry related, one not. Anyway, so that is how we name ionic compounds and molecular compounds. Definitely check those out. And we are going to go do transition metals and polyatomic ions in the next lecture.